I've got two problems up on the board here. Both of them ask us to find the area of a parallelogram determined by two vectors. So it looks like they're very similar questions, and they are, but I'm going to use very different techniques for doing these two problems, because the first problem is in 2 space, and the second problem is in 3 space. Now, we just learned that the area of the parallelogram determined by two non-zero vectors in 3 space is just the magnitude of the cross product. So that's how I'm going to work out the second problem. But for the first problem, I can't cross A and B. They are not in 3 space. So that's not defined. Remember, we learned that if I form a matrix A, where I can let A and B, my two vectors, be either the rows or the columns. I'll let them be the rows. So my matrix A would be 1, 5, 2, -1. The absolute value of that determinant will be the area here. So I've got a different technique for calculating area. I can do it in both spaces, but in 2 space I take the absolute value of the determinant, and in 3 space I take the magnitude of the cross product. All right, so let's go ahead and work that out. Okay, so for this first question, it would be the absolute value of the determinant of A. Now the determinant of A is a number, so that's how I know these vertical bars mean absolute value. If I just put A here, that would mean the determinant of A, but I want the absolute value of the determinant of A. So let's see, the determinant would be -1 minus 10, so that's -11. Absolute value of -11 is 11. So the area of this parallelogram would be 11. For question 2, it's going to take us a little bit longer because we've got to first of all work out what the cross product is, and then we can find the magnitude of that cross product. Okay, so let's just work out V crossed with W. That's going to be our symbolic determinant, I, J, K, 1, 0, 2, 2, 4, -1. And I'm going to suggest you actually pause the video here, work this out, and then just tune back in to check your answer on that. So go ahead and do that, finish off this problem, tune back in, and just double check your answer. I'll see you soon. I've got the answer up here. The cross product should have been -854. Do make sure that you got a +5 here. Remember, when we're working things out, for the J component, we don't get this determinant, we get the opposite of this determinant. So I usually just calculate it backwards. That would be 4 minus a -1, or 4 plus 1 is +5. All right, so then we take the magnitude of that vector. We just get the square root of 64 plus 25 plus 16. So our final answer there is the square root of 105.